This is the first of two videos where we'll introduce the steps involved in designing a misting system. In a subsequent video, we'll try to make that process come to life by applying those steps in an example. Let's start by discussing the overall objectives of a good installation. The system provides good coverage, that is, there are enough nozzles located in the appropriate places with sufficient pressure at each nozzle to ensure a good flow rate. The nozzle circuit is installed cleanly and essentially disappears into the property. We've minimized the probability for off-property drift of the insecticide, and to the extent possible, we've protected the nozzle circuit against damage caused by the yard service, weather, or animals. All of these are important objectives. To ensure that they will be met with every installation, we recommend you follow a 5-step design process that goes like this. Step 1. Survey the property and conceptualize the path of the nozzle circuit. Step 2. Identify specific locations or surfaces available for nozzle installation and consider transitions from one surface to another. Step 3. Decide where to place the misting control unit. Step 4. Make a scale drawing of the installation plan. And finally, Step 5. Use the pressure engineering rules developed in the fundamentals videos to anticipate pressure issues in your design and engineer around them. Now let's briefly touch on each of these steps. As we go through each of them, we will also develop a list of guidelines you can follow as you design your systems. In this step, you will make a thorough inspection of the property and conceptualize the path of the nozzle circuit. There are 5 key parts to this step. We'll list them all and then briefly touch on each. First, envision what we call a perimeter of protection. Second, consider the prevailing wind and potential for drift. Third, identify whether interior nozzles are required in addition to the perimeter nozzles. Fourth, identify areas that may require extra treatment. And fifth, recognize features that require special consideration. Let's start with what we mean by perimeter of protection. The systems are most effective when the nozzle circuit traces a perimeter around the area you wish to protect. In addition to creating a boundary that insects are not inclined to cross, the mist can readily drift through the interior of the area, no matter which direction the wind is coming from. So this concept becomes guideline number 1, design a perimeter of protection. Next is guideline 2. As a general rule, nozzles along the perimeter are placed 10 feet apart. The 10-foot separation guideline has emerged from field experience and is confirmed by observing the shape and dimensions of the conical spray pattern of the nozzles. In general, if they are placed further apart, there is a risk that some areas miss coverage, and if they're placed closer together, it may be overkill. For the vast majority of homes, the perimeter is created around the backyard, with the nozzle circuit running along the back of the house and along the property lines on the sides and back. To illustrate, let's look at a layout that has an effective perimeter of protection. Here's the house, the garage, the patio, the backyard, and the nozzle circuit. Note how the nozzle circuit traces a loop around the backyard. In this drawing, in addition to the backyard loop, there are nozzle runs that extend into the front yard that protect the front door. Now, for clarity, let's take a look at a couple of schematics with perimeters that will not be effective. In this drawing, the nozzle circuit is installed around the perimeter of the structure itself. It is unlikely to work well because the mist will not drift through the property. Similarly, in this drawing, the nozzle circuit is installed around the deck or patio only. The area is too small and the volume of mist too small to be effective. In some cases, it is very easy to conceptualize a perimeter. There are privacy fences along property lines that make an ideal surface to install a nozzle circuit. In other neighborhoods, landscaping beds where you can install risers delineate property boundaries. Virtually every home with a swimming pool has some kind of fence surrounding it, making it a logical structure for at least part of a nozzle circuit. Other neighborhoods and yard layouts can present more challenges. Now let's talk about an important factor that should influence your nozzle circuit path and specific nozzle placement: wind drift. On-property drift is desirable. In fact, it assists in dispersing the insecticide and improves the coverage and effectiveness of the system. Off-property drift, though, is not. You should consider the possibility of drift as you plan your installation and place nozzles in a way that minimizes drift off of the property. For example, in many areas along the coast, the wind almost always blows from water to land. In this case, mist from nozzles positioned on the lee side of the house would drift off property. So guideline 3 is consider the prevailing wind as you plan the nozzle circuit. Now let's talk about interior nozzles. For properties with large perimeters that contain interior harborage areas, to ensure adequate coverage, it will probably be necessary to install interior nozzles with runs that originate at the perimeter and end in the harborage areas. Sometimes trees in the interior can be used to mount nozzles. Other times it might be necessary to bury tubing to supply risers that are installed in the interior landscape beds. For example, due to the size of this property, interior nozzles would be needed to provide enough coverage. They could be installed in the landscaping beds and on the fence surrounding the pool, accessed by buried runs from the perimeter. So guideline number 4 is, use interior nozzles if the perimeter is large. Next, consider whether parts or all of your installation might require you to increase the nozzle density for the system to be effective. Areas which might require extraordinary treatment are landscape beds that are either exceptionally lush or dense, or too broad for a single rank of nozzles to cover thoroughly. So guideline number 5 says you should consider making an exception to the 10-foot guideline when the mosquito problem is really bad, or if the landscaping or canopy is exceptionally lush or dense, or if a landscaping bed is too broad, say wider than 10 feet, for a single rank of nozzles to cover thoroughly, or if the property can be very windy, at a beach house for example. In each case, you can place the nozzles closer together, 8 feet rather than 10 feet, or even consider installing parallel runs of nozzles. And finally, there are a few other features that deserve your special consideration as you plan the path of the nozzle circuit. Bodies of water. The labels of the insecticide all caution against use near water because pyrethrins and permethrin are toxic to fish and other aquatic invertebrates. Although the mist is already very dilute and would almost certainly not result in a fish kill, the label is the law, and you must comply as you consider proximity to water in your layout. Koi ponds. Avoid placing nozzles very close to koi ponds. We have done calculations using toxicity data for the insecticides, and the issue is more perceptual than real. However, if an expensive koi dies and you've installed nozzles close to the pond, the system will probably get the blame. Swing sets or jungle gyms. Consider appearances and use good judgment. Avoid installing nozzles directly in these play areas, and especially avoid placing nozzles where a small child has access to them. Exercise care in your planning when you run across any of these features. You can usually find a way to avoid them and still design an effective system. That's all for step 1 in conceptualizing the nozzle circuit path. In the next video, we'll take up the system design process starting with step 2 and identify specific nozzle installation locations.